Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another 2D hack and slash video. In this video, we're going to be adding simple kind of a screen shake or view object to the game. So we'll improve the way our view looks and moves just a little bit, and give it a bit of a screen shake too. So let's start off by creating a new object. And we're going to call this O_camera. And we're going to want to get our view's current width and height. So we'll store these in variables. View width equals camera get view width, and then we have to pass in a camera right here, and we're going to use view camera 0. Okay, so where do we get this 0 from? Why are we doing a 0 there with the brackets around it? Well, there are multiple view cameras, and if we come into our room right here, and we come down into viewports and cameras, you can see that we're currently using viewport 0. And so that's where the number 0 comes from, is right here. If you were using a different viewport for whatever reason, then you would need to use that number instead. We'll also need to get the view height. Let's actually just call these width and height. We'll just call it width, height, because they're inside of our camera object, so that already gives us context. So we'll get our height, view camera 0. There we go. And once we've done that, what we need to do is so we currently have our camera set up to follow our player right there. But we're going to turn off default object following. So right here where it says object following, we're just going to set this to none. Because we don't actually want to follow we don't want to use this object following. We're going to do our own. So inside the camera, we're going to add a new step event. And we're going to move this object, so not actually move the camera yet. We're just going to move this object to be where the player is. So we'll say if not instance exists O_skeleton exit. So we want to exit this event if the skeleton doesn't exist. Then we can follow the skeleton. So we can say x equals O_skeleton dot x, y equals O_skeleton dot y. So this will make this object follow the skeleton. And if we assign a sprite to it, just for now, let's see. Maybe we could do, we'll just do the wall for now. And then we put it in our room. You'll see that the wall object now follows our player around. Well, you would see that if our camera was low enough. So let's now set our camera's position to this object's position. So camera set. And this is a place where it's going to be quite different in GameMaker Studio 1.4 versus GameMaker Studio 2. In GameMaker Studio 1.4, you can just do view X view and view Y view, and those are variables, and you can just set them. So it would be like view x view 0 equals x, something like that. So it's quite a bit different, but you can look at the GameMaker. If you're doing this in GameMaker Studio 1.4, you can see the you can see the code that's in GameMaker Studio 1.4. I think that my Screenshake, I don't remember whether I have a view object or whether it's set up in the game object or something, but you could do a project-wide search for those variables and find it. So we're gonna do, let's see, camera set view position, just like that, and we're going to pass in a camera, which is going to be view camera again, view camera 0, and then we need to pass in x and y, and so we're going to pass in this object's x position and this object's y position, like that. And then you can see now that didn't work quite how we wanted it to. So why isn't this working? Well, the problem here is that when you set the camera's position, it sets the camera based on the very top right corner of the camera. So basically we're taking this point of the camera right here and attaching it to the player right here, because this is the player's X position down here at the bottom, isn't it? Pretty sure it is. I'd have to look at our sprite. But yeah, clear down here at the bottom, right? So it's taking this point on the camera and lining it up right here with the bottom of the player. Well, that's not what we want. We want the center of our view to be lined up with the center-ish of the player. And so in order to do that, we have to offset half the width and half the height. And hence why we got the view's width and height in the create event right here. So now we can do x minus width divided by 2 and y minus height divided by 2. Okay, and that will make it so that the center of the camera, our object is still in the correct position, but now we need to make sure that the center of the camera is in the correct position, and this should do it for us. But you can see it's still setting it clear down here, and that's not good. It just shows a lot of ground for no reason, which also you can now see the camera object there a little bit. So let's actually assign an experience to the camera object so that you can actually see it moving now with the player. You can see exactly where the center of the camera is now. And if you want to remove that, you can just uncheck visible on your camera object. And so then that's helpful for debugging purposes. If you ever want to see where your camera is, you can just check visible. Okay. So now that we've done that, we need to change our Y position a little bit as well so that our camera isn't following the skeleton's Y position exactly. So let's go up just a little bit. And I'm thinking I'm just going to put in a hard number here and see how that goes. Okay, so we're still getting a pretty, let's put visible again. We're still really close to the player's position, and that's not really what we want. So let's go quite a bit higher. Okay, now you can see where the center of the camera is. That seems like a pretty good height to me. Now, if you want to do the quick and dirty way of making this camera a little bit more fancy, you can use a lerp function, and you would do lerp, and then you have current position, which is X, a target position, which is the player skeleton X, and then you'd have a lerp amount. I'm going to do 0.3. That would be basically move 30% towards your target. And this is the quick and dirty way to create a camera that moves a lot smoother towards the player. And it can cause, you can see some sprite jittering because our camera has subpixel movement. There are ways to fix that, but it's complicated, so I don't really want to get into it. But if you're looking for something like this, a slightly smoother camera, you can do that. Now, one other thing we can do is allow the player to, and I'm going to actually leave this in because I don't mind the slight jitteriness. If you don't want it to jitter, just make it follow exactly. But then you won't be able to do this next step, which is instead of following the player's X position exactly, we're going to go a little bit into the direction that the player is facing. So X plus O underscore skeleton dot image angle or image X scale. So that's the direction we're facing, right? Times, let's go like 32 pixels forward. So this will go 32 pixels in the direction that the player is facing. And so now you can see we have a little bit of, we can see a little bit farther, and maybe 32 is too far because look, we can see the edge there. But this allows the player to plan a little bit, though switching back and forth like that is a little bit jarring for me. So maybe a smaller amount is better here. It's still kind of jarring. I don't remember the values that I have in the original one. It's not too bad. But yeah, it gives you a little bit of visibility forward. And if you slow this down, so if you do like 0.2 here on our linear interpolation, we're going to get a little bit less of a jarring camera movement. So 2 seems to be a pretty good amount. Our parallax isn't working correctly. Oh, my phone just buzzed at me. So our parallax isn't working correctly. It's because we're basing it off the skeleton's position. So now what we'll want to do is base it off of the camera's position. Because they're not always the same now. And that's it. That should fix it. Once we've got the camera. Yeah. Interesting. It's definitely still a little bit jarring. I'm gonna take out this right here. I'm doing this whole section a little bit on the fly because it's different than the original game. Honestly, this doesn't give you as much view forwards, but it feels so much nicer to have it like this, in my opinion. Oops. Still feels like the clouds seem weird. Don't they seem weird? I don't know. Something seems off with the clouds in the parallax. I'm not sure exactly what it is. It is a bit late, so maybe that's why, but they just seem like they're acting a little bit weird. Anyways, let's add in our screen shake now. So I want to create a script for this to make it easy to call from other places without having to worry too much. Let's close all these windows. Let's create a new script, and we're going to call this one add screen shake like this, and we'll give it 2 arguments, which will be a intensity and a duration, or an amount and a duration. So arg intensity and arg duration. Intensity equals argument 0, duration equals argument 1. And then we'll say width. Let's see, we'll say if not instance exists, object camera exit. So we need to make sure the camera exists. Then if it does exist, we can do some stuff with our camera. So with object camera do stuff. And we'll say screen shake equals intensity and alarm 0 equals duration. Okay. Save. Now we can come back into our camera object, and we need to create the screen shake variable. Holy cow! Screen shake. I'm a little bit tired. Screen shake equals 0, and then we don't need to set our alarm yet, but we'll create an alarm 0, and in this event we'll set screen shake equal to 0. So this basically just, when the alarm goes off, it turns off screen shake. So while screen shake is on, we're going to basically change the position of this camera. So we'll say let's create some variables here. So we'll say var target x will be equal to o underscore skeleton dot x plus random range negative screen shake and screen shake. So this is going to change what our target x position is based on the skeleton's x position plus a random range of screen shake. So screen shake is 0, then we're just going to be the x position. But if it's like 8 or something, then it could add a random amount to this x position. And we'll do the same thing with target y. And we'll just copy this right here. And then we'll say plus random range. It's actually going to just be the same. There we go. And then in here we have target x and target y. Like that. Now we should be able to add screen shake, and we'll want to do that when the player takes a hit. So come into the skeleton and come into our, actually it's in our hitbox object. In the hitbox object, we know when we've hit a skeleton, right? Right here, when we create bones and stuff, we've hit one here. This is where we can add some screen shake. So screen, add screen shake. We'll do an intensity of 8 and a duration of 8 frames. I don't know. I'm just making stuff up right now. We'll see how it actually looks. So the lerp might affect the screen shake. So we may have to have some sort of a solution for that, but let's see. So yeah, we didn't get any screen shake there. So let's try and figure out what's going on here. So Let's check our ads. This is a good debugging thing. So with object camera, screen shake equals intensity, alarm 0 equals duration. So let's actually print. Let's do show debug message screen shake. So let's make sure that screen shake is actually being set. So it is being set. You can see down here in the bottom. There it was again, 15. What? Why was our screen shake 15? That's really weird. Add screen shake with object camera. Screen shake equals intensity. Intensity. Alarm 0 equals duration. Duration. Let's come back into our camera. Let's just set our position here instead of linear interpolating. I'm just going to comment this out and just test. X equals target X, Y equals target Y. Let's see how this does. Do we get any screen shake? Nope. Nada. Equals skeleton.x plus random range screen shake. Should be fine. Oh, it's only going to do it when we die. Because we're only adding screen shake when we die, I think. But we're still not seeing screen shake because our camera only updates our position if the skeleton exists. So that's where our issue is. We're only creating screen shake when we die, but then our camera doesn't actually update its position when we're dead. So that is very, very flawed logic, right? So what we'll do here is we'll just say X plus equals random range. And we'll just add this to our X position. And Y plus equals random range, and add that to our Y position. And we can take it out of here. What that's going to do is just make sure that screen shake gets applied no matter what. And then we just re-update our X and Y position here. Every frame. Let's see. Let's see what it looks like. I don't know. Is that even going to work? This logic is okay. So we got some screen shake there. Looked pretty bad, to be honest. But at least we got some. So let's try adding our lerp back in. We really need to set it up so we get screen shake the whole time. Let's make it so when we click, we get screen shake. So I'm going to come into our skeleton object. No, let's come into our camera object. I'm going to add an event. Let's see. Mouse. Global. global left pressed, add Screenshake. We'll do 8 and 15 frames. There we go. Well, honestly, that doesn't look too bad. I think the intensity is a little high, but like I was expecting it to look super terrible, and it doesn't. Yeah, this isn't a bad solution. Let's set our Screenshake intensity a lot lower. And we'll set the duration lower to something like 8. And let's make it so that when we get hit, it actually does it every time we get hit. So in here, what we need to do is separate out this logic right here into its own if statement. If. That way, everything that happens in this for loop for when we're creating the death stuff can only happen when we die, but we can add Screenshake every time we get hit. And we'll do 4 and 8. Like that. So we don't just get Screenshake when we die now, we get it every time we get hit. It feels, I don't know. You can kind of play around with the different amounts. I'm gonna delete this for now. I may refine this in a future video, but I think this is a good start, and I'll think about maybe some ways to refine it and potentially do that in a future video. But you can kind of play around with these durations and amounts till you get something that you feel like works good for you. And because I think everyone likes different levels of Screenshake. See, that's just a little much for a single hit like that. I don't know, but you want the player to know when they've been hit, so sometimes it's good to actually do a lot. I guess once again, it's personal preference, but the player's definitely going to know when they've been hit if you have that amount of Screenshake on. And that kind of visual feedback can be really helpful. So thank you guys so much for watching this video. I hope you enjoyed it, and I will talk to you all later.